Section 1.2, Exploration of Patterns. So what in math is really kind of a science of patterns and figuring out how we can deduce additional information from patterns. And when we're looking at reasoning, there are things we look at from observations, and then we can go through proof and then come to a place of where we can prove what we think and come up with like an equation or theory. So inductive reasoning is the first type of reasoning really that happens because we start to make generalization based on observations and patterns. But that isn't enough because our inductive reasoning can have exceptions. It is deductive reasoning that we need to get to math because we take the observations that we have seen, but then we use definitions and terms and logic proof to come up with a conclusion. So in looking at these two types of reasoning, we're going to take a look at sequences, which is an ordered arrangement of numbers, figures, or objects. And this is an example with matches that is found in our text. So if we look at the sequence of matches, notice they're divided by a comma and they are in a specific order. The sequence that we can come up with is we could start with there are 4 matches. And then our second term, there are 7 matches. And then our third term, there are 10 matches. And in our fourth term, there are 12 matches, or sorry, 13 matches. We can look at these numbers of matches, and if we start with our existing sequence, what we notice is that we are adding 3 each time. From 4 to 7, we add 3. From 7 to 10, we add 3. From 10 to 13, we add 3. And so the next 3 numbers, we know we can use our inductive reasoning, right? That there is a concrete pattern and have deductive reasoning. We can go to, is it going to be 16, 19, and 22 would be the next 3 terms. So in looking at this, one thing we want to do is to find a pattern that we can look at mathematically. Now, for this, I want us to notice that with our first term. How we describe mathematically our first term in this sequence is that we could say that our first term would be a sub 1. Maybe a is the sequence. A sub 1 is 4. Then we would say the second term, we're going to name it a sub 2 is 7. And then we're going to say the third term, a sub 3 is 10. And the fourth term, a sub 4 is 13. Now, if we compare the number of the term with the term itself, we can hopefully come up with a pattern. So the pattern for finding terms with the sequence is with a sub 1, when n equals n, because it would be a sub n. So when a sub n is equal to a sub 1, when a sub n equals 1, then our term name a sub 1 is equal to 4. When n is equal to 2, and our term name would be a sub 2, our term is 7. When n is equal to 3, our a sub 3 would be equal to 10. So we look at a combination between the number of term that it is and the value of the term. Again, for instance, when n was 1, looking at the first term, the value was 4. When n is equal to 2, the value of the second term is equal to 7. When n is equal to 3, the value of the third term is equal to 10. So in this instance, what can we say? Well, the conclusion that I'm making is I'm adding 3 to every term, 3 to every single term. But I know that my first term, so our pattern would be add 3 to every term to get the next term. Okay. So can we come up with a table? Can we come up with a table for this? And I would say Yes, or can we come up with a formula? The answer is yes. So when I looked at a sub 1, or the first term, I get a 4. When I look at the second term, a sub 2, it's going to be 4 plus 3. When I look at the third term, I get 4 plus 3 plus 3, or 4 plus 2 times 3. When I look at the fourth term, I get 4 plus 3 plus 3 plus 3, or 4 plus 3 threes. Now I get this combination, and when I look at the nth term, so they want a formula. So we're going to say it's the nth term. It's a generic term. I'm going to have a 4 plus how many threes? Well, in the second term, I had 1 3. In the third term, I had 2 threes. In the fourth term, I have 3 threes. In the fifth term, I'll have 4 threes. Now notice that that is always one less than the term that we have. And so I'm going to say it's going to be n minus 1 times the 3. And this would be a generic formula for our term. But we can also say, if we simplified it, it would be 4 plus 3n minus 3. You know, I would distribute that 3 forward into the n minus 1. Or a sub n is equal to 3n plus 1. And you can test this with the sequence above. Now, when we look at the general form of the arithmetic sequence, it does follow this form. The book wants you to discover it for every sequence, but there is a pattern. And the pattern that we have is that our sequence, like a sub n, will always be an initial term. So that will be our first term, a sub 1, plus n minus 1 times d, where d equals the common difference. And the common difference is the fixed number. So when we look at these, and an example here is we have the sequence 2, 6, 10, 14, 18. Well, in this sequence, I want us to see that we are adding 4. This difference between all of the terms, we increase by 4. So our difference, our common difference would be 4. Our first term is a 2. So if I want to look at the formula, the generic formula for the sequence of 2, 6, 10, 14, 18, we would say it's a sub 1, or 2, plus n minus 1, n being the number of term that it is, times 4. And if we were to simplify this, it would be a sub n is equal to 4n minus 2. Now 4n minus 2, so that means our third term, let's just go ahead and take a look, is 4 times 3 minus 2. 12 times minus 2 is 10. And look at that, the 1, 2, third term is the 10. Now let's do a few examples of this. It says find the first 4 terms of a sequence defined by b sub n is equal to 5n plus 2. All right, the first 4 terms. So b sub 1 will be 5 times 1 plus 2, or 7. The second term is 5 times 2, because n is equal to 2, plus 2, or 12. b sub 3 is 5 times 3 plus 2, 17. And b sub 4 is 5 times 4 plus 2, or 22. Now notice with these, the common difference is 5. It's that number that's multiplied times the n in the sequence. And our first 4 terms would be 7, 12, 17, and 22. So these were all arithmetic. Okay, but let's take a look at the next sequence. In this sequence, we're given a generic form, and we're asking, is the sequence arithmetic? All right, well, let's take a look at the first 4 terms first. We have a sub 1 is 1 squared minus 3 with 2. A sub 2 is 2 squared minus 3, or 1. A sub 3 is 3 squared minus 3, or 6. And A sub 4 is 4 squared minus 3, or 13. So when we look and list the values out, it's clear this is not arithmetic. So the answer would be a no. It's not arithmetic. And the reason that it is not arithmetic, look at, we increase by 3, and then we increase by 3, and then we increase by 3, and then we increase by 5. All right, so there's 3, there's 5, and then there's 7. So the amount that we increase or decrease is not the same. So it's not arithmetic. There is no common difference.